Okay, let's start. We discussed numerical problem from what? Bart Savatlo na? Yes or no? And MPS circuit law. Clear na? In last class. Now we are proceeding with what? Solenoid. Okay. Let's start. Have you heard this name? Solenoid. Solenoid. What is this actually? What is this actually? It is a coil. Means there are number of circular rings are there connected to each other in the form of helix. Yes or no? Helical forms. Yes or no? Means they are at a smaller distance now, they are compact. Yes or no? And like this. Like what? I am drawing this figure here. Yes or no? Like this now? Yes or no? This is solenoid. If I remove this one, this line is not able to. This is not a wire actually. Okay, I'm just for drawing. I wrote this. This is like this now. Is it a solenoid? Yes. Can you see that 3D figure? Imagine the 3D figure. This is a solenoid. I can pass current I through this solenoid now? Yes or no? Are these, if you talk about one single turn, is this a circular ring? Yes or no? Is this a circular ring? Means I already have calculated magnetic field due to this circular ring now. At its center as well as at a distance x from its center, at its axis. Yes or no? What was this magnetic field? Dx. What was this magnetic field? Mu naught n I r square upon r square plus x square power 3 by 2. If the radius of this circular ring is r, current bearing ring it is. Clear? Yes or no? Okay. There are number of rings na? We will have to calculate magnetic field due to number of rings. Yes or no? Where we calculated magnetic field? Either at center or at a point in axis. Means here let's calculate the magnetic field first. And already I have taught you the magnetic field. These coils are arranged in such a way that the magnetic field inside this solenoid should be what? Uniform. Helmholtz coil arrangement. Have you studied now? Means what was the graph actually? Means if I draw B across B and R, it was like this. It was like this. When it was means curve was getting changed, it was again up. Means it never come down na. Means it is going to be nearly straight. Clear? It is going to be nearly straight. Means it will be uniform inside this. Magnetic field will be uniform inside the solenoid. What about outside? I will discuss everything. What about outside? Outside, imagine I am taking two circular, consecutive circular rings. Clear? Consecutive means one besides the other. Clear? Okay. Due to this, if the current flow is same, because if you can imagine the current flow is same. Yes or no? It's in, if this is upward direction means clockwise, this will also be clockwise, means every ring will have same direction. Yes or no? Okay. Due to this, where is the actually I have drawn. What was the direction of magnetic field due to this? means here it will be in what? No doubt. What about the other things? It is like this or no? Yes or no? It was like this, no? It was like this, yes or no? Can you imagine? Here it will be like this, no? Means it will come and it want to rotate, now again here due to this means ring is like this, no? It will come down. See, it want to go up, it want to come down, no? Yes or no? Yes or no? They will not allow any magnetic field outside this because they will cancel each other or no. There is magnetic field due to this, na? If they are opposite to each other, what will be this magnetic field? Zero or no? Zero or no? Imagine they are. If this magnetic field is in this direction, if this is in this direction, they will cancel each other, na? Because see, if they will touch each other or no? Definitely at a point they will touch either at the same point. There is two direction of magnetic field opposite to each other, na? Yes or no? They will cancel each other or no? Means outside this ring the magnetic field will be what? Zero. What about between them? Imagine both are in the same direction or no? Both are in the same direction or no? What about between them or along the axis? They will be in the same direction. What about here? Here one is going up and another is coming down. Yes or no? They will cancel each other. But here they will support each other. Yes or no? That's why inside a solenoid we will calculate a magnetic field. But what about the outside? It will be nearly zero. Not exactly zero because there are some lines which can represent the magnetic field there. But it is nearly zero. Clear? Clear to everyone now? Okay. Means we will have to calculate the magnetic field inside only. Let me calculate the magnetic field inside. Okay. Understood now why there is no magnetic field outside? Because of cancellation. Because they will cancel each other. Let's calculate. I am drawing this figure in what? I am taking the cross section of this solenoid. Can I take this cross section? Means if this is the solenoid, I cut it in between the means diagonally. Clear? Diametrically means in the laterally. Okay, this is lateral, na? Okay, I cut it. What the cross section will be like? Means each wire have some cross section, na? Only cross sections of the wire can be seen. Yes or no? Imagine. Can you see the cross sections? And directions of electric current? This is inside. This is coming out, na? See here. Coming out and going down. Coming out and going down. Yes or no? Correct? Clear to everyone? Cross section means when you will cut it, what you will see? Each wire cross section only or not? Means back side you can see, back side wires you can see. You cut. I am just drawing the cross sections of each wire here. Clear? Clear to everyone or no? And you cut it like this. Okay. Now I want to calculate magnetic field at any point in between this solenoid. Okay. To calculate the magnetic in between at any point, let's consider a section of this solenoid. I don't know the length of this solenoid. Yes or no? Let's say this is capital M. I'm assuming it may be of infinite length. It may be of infinite length. Clear? It may be of, but I'm considering it finite. Why? I will tell you. This will be for finite. I already considered. Yeah. Do you remember the magnetic field due to current carrying straight wire? I considered one first finite and then calculated for infinite. Na? Same thing I will do here. I am calculating for finite length. What is this length? L. Is it okay? Okay. Means this is the length of the solenoid. Yes or no? And number of turns here is capital N. How many turns here? Capital N turns. What about the number of turns per unit length? N equal to N by L. Yes or no? Yes or no? Now, I am assuming a small section of the means this is I am assuming a small section means 3-dimensional small circular section it is actually. Yes or no? I took this section here. Yes or no? Of length what? Dx. Is it okay? Means what was the length actually? L na initially. I took dx there. Clear to everyone or no? Yes. I assumed a point P where I want to calculate magnitude of magnetic field due to this. Yes or no? If I want to calculate magnetic anywhere in between them, not only on the axis, it may be up means beyond the axis or below the axis. Clear? Oh. It is at a distance what? X from what? From this section. Clear? Clear? I want to calculate magnetic field here. Okay, let's do it. Tell me, what will be the magnet here? Initially it was making angle what? Theta 1. With what? With what? With one end. And it is making theta 2 with what? Another end. Yes or no? Theta 1 with one end, theta 2 with another end. Is it clear to everyone? Okay. Now, what angle is making this section? Let's do it. Let's say this is what? Theta. Clear? Clear? This section is making theta with this point. Clear? Clear to everyone? Okay. Okay. Is this a ring? Actually, I took a section of the solenoid. No? Is this looks like ring? Yes or no? Yes. Will this look like ring or no? Like this, no? Like this. I took section of this. It will behave as a ring, na? Current carrying, and the direction of current is on the same direction. Yes or no? Is it a single ring? No, no. There are n number of turns, na? From n number of turns, I took few number of turns here in this section. Yes or no? How many numbers of turns are there? I don't know. How can you calculate? You know na number of length per unit, number of turns per unit length. And if you multiply with this dx, you will get the number of turns or no? Means number of turns in the small section. Small section is what? This is not actually, this is number of turns per unit length. What will be number of turns? Means n dash na? Yes or no? Means you can also type like dn. Yes or no? dn na? Is it dn? Is number of turns per unit. Length into number of part. Is it n into dx? Yes or no? Yes. Is it n into dx? Clear to everyone or no? Okay, sir. You got na? Now it is total number of turns inside this solenoid. Now tell me the magnetic field. Magnetic field due to a small section. Current carrying element, you can also say current carrying section What is this actually, ring na? Yes or no? Current carrying ring. What will be this magnetic? Is it visible to everyone? Okay. dB equal to what will be the magnetic field due to this? Means this is ring. Due to ring at a distance x, what is the formula? Mu naught I and n was there na, and means dn will be there. Yes or no? Mu naught dn. Yes or no? Okay. Mu naught dn I r square upon root of not root over r square plus 2 into r square plus x square power 3 by 2. Yes or no? Is it dB? Got everyone or no? Okay. Now, what will be the magnetic field? Put the value of dn here. Yes or no? Means dB equal to what? Mu naught in place of I. Yeah. What was? Where is I? Oh, I is there. Huh? What is dn? And dx into I r square. No, not r. R square was there. Yes, r square. Okay. What about the denominator? 2 into r square plus x square power 3 by 2. Is it clear to everyone? Okay. Now, dx is there, right? Mu naught and I r square upon 2 into r square plus x square power 3 by 2 dx. dB is clear to everyone? dB is clear to everyone, no? Okay. Now, I want to put the value of dx in terms of d theta. Yes or no? Because we have assumed limits from theta 1 to theta 2, no? Yes or no? One is making theta 1, one other is theta 2. Clear? Initially it was theta 1, finally it was theta 2. Let's convert it into theta. And to convert it into theta, you just need to what? Need to use what? Trigonometric ratios, no? Sin theta, cos theta, tan theta, like. Come to this figure. This figure. Right angle, is it right angle triangle? Yes or no? Take tan theta. Tan theta equal to what? Is it r by x? What is r? R is the radius of this. Radius of this means this is. The radius of this ring is r. Yes or no? Radius of the solenoid is r. Is it r by? It will be r, no? Here. From here to here. Yes or no? Here, this one. Is it r? R by x. Clear to everyone, no? P by b actually. What is x equal? X equal to r cot theta. Yes or no? Means tan theta will come down. R cot theta, no? Now I want to differentiate it. dx equal to r. Tell me. What is the value of cot theta? What is the value of differentiation of cot theta? What cot theta? Do you remember? हाँ? tan नहीं है ये, cot है. Cosec minus cosec square theta. Is it c? Yes or no? I already told you na. Whenever you find c, it will be minus cosec square theta d theta. Is it clear to everyone? Now we got dx, no? Can we plug this value here? Yes. And in place of x, I also can put this value, no? Now let's plug this value. dB equal to mu naught I, n was also there, n I r square upon what? 2 into r square plus in place of x r square cot square theta, na? Yes or no? In place of dx minus r cosec square theta d theta. Is it clear to everyone? Okay, good. dB equal to mu naught this is 10, na? And I r will come out, and can I cancel it? 1 plus cot square theta formula. Huh? Forgot the formula. 1 plus cot square theta. Cosec square theta. Forgot this? Yes sir. No sir. Mu naught n I r square upon r square got cancelled. Should I write it again? No, no. Mu naught n I. Okay. What about this term? 2 into 1 plus cosec square theta. Yes or no? What about this? Minus r was there, na? Let's take it out. Yes or no? What is left? Cosec square theta. Is it cosec square theta? And here, what was that? Cosec square theta. Actually, here 3 by 2 was there, na? Where is 3 by 2? Yes or no? Let's put this. Now it will be r cube, na? Which r cube will come out or no? From this. Because 3 by 2 was also there, na? Means 2 to cancel, 3 will be left. Yes or no? Okay. Means r cube, 1 r will be left here. And 1 r is also here. Yes or no? Now it will get cancelled. Yes or no? Clear too? Should I write it? No. No. Don't write it. Okay. Now what is left? It is cosec cube, na? Yes or no? It is cosec square theta d theta. Now 1 will cancel, na? Means 2 will cancel, 1 will left. What is dB here? Minus mu naught n I upon 2. What about this? Is it 1 by cosec means sin theta, na? Yes or no? I want to integrate it now. I want to integrate it now. Can I do it? Why I took this out? Because these are constant. Let's take them out. Yes or no? What about the limit 0 to b? What about this limit? Theta 1 to theta 2. Yes or no? Theta 1, theta 2. Clear? B equal to minus, what about sin theta? Integration of sin theta? Minus cos theta. Why you forgot this? Should remember everything. Okay. Minus minus will cancel, na? Means mu naught n I upon 2 minus cos theta from theta 1 to theta 2. B equal to minus minus will cancel. Yes or no? Yes. Now what is the answer? Mu naught n I by 2 cos theta 2 minus cos theta 1. This is the final result we obtained. Means magnetic field due to a finite solenoid, inside a finite solenoid is what? Mu naught Ni by 2 cos theta 2 minus cos theta 1. We got the result. Yes or no? Very important result it is. So remember the result and also go with the procedure what I am through which I derived this. Yes or no? Copy this. Copy this. Copy. Operate this one, na? Okay, no problem. Do it fast. What about we got the result for finite solenoid? Na? Yes or no? Isn't it? What about infinite solenoid? Let's calculate. Before going to infinite solenoid, can you tell me what will be the magnetic field here? Means let's say this is a solenoid. This is a finite solenoid. Clear? What about the magnetic field just at the ends? At the ends. We know magnetic field inside the solenoid is same and uniform. Yes or no? What about at the ends? Is it same or different? Can you calculate using this formula? Yes or no? Yes or no? During the current carrying straight wire, we had a question na, at the end of the conductor, at the end of the wire. Yes, if it may be infinite, but in one end, in other end it may be finite. If you are asked to calculate magnetic field here, what you did there? B equal to mu naught I upon 4 pi r sine what? Sine one angle is 0, other is 90 na? Yes or no? Sine 0 plus sine 90. You put it this na? Yes or no? And you got result what? Mu naught I upon what? 4 pi r. Yes or no? Yes or no? This was the result na? You got there. What about this? I want to calculate magnetic field here. Means at the one end. Can you calculate the magnetic field there? Yes, we have the formula. What is that formula? Mu naught n I upon 2 cos. What about theta 1 means? I want to calculate here. What is the angle bit of this to this? Is 0 no? What is that? What is the angle making with this? Means if it would have been here, it would have been theta 1. Okay. What about this? This got 90 na? Actually 90, actually not theta 1. This got 90 na? This got 90. Yes or no? It became increasing, it was increasing na like this. Yes or no? Finally it got 90. Yes or no? Yes. Theta 1 is 90. What about theta 2? Here. It is approximately 180. Yes or no? It is approximately 180 degree. Yes or no? Theta 1 is 90. Theta 2 is means here from here. It is approximately 180 degree actually. Clear na? And the point is here na? Not here. Clear? Clear na? Yes, sir. Okay. This is 180 degree. Put the values. No, not here. Yes. Cos theta 1 is 90. Theta 2 actually it is na? 180 minus cos 90. Clear? What will be the result? Minus 1. Cos 180 minus 1. Cos 90 0. It will be minus 1 na? Minus mu naught ni by 2. Why minus? I am telling you. The direction where we have choose the direction. This one na? It was in this direction. Means the direction we have, the direction of magnetic field we have chosen positive in this direction. You got here. And already in vector I have told you that magnetic field is a vector or a scalar? Vector. So don't go with the negative sign. Okay, in vector don't go with the negative sign. You already have idea where will be the direction. Negative sign represent what? In vector what it represent? Only direction. Clear? You already have the direction. Why you will go with the negative sign here? Yes or no? So always go with positive. Okay. If there is negative sign, skip this. Take the mode. Yes or no? What is this result? Mu naught ni upon 2 no? This is the result for what? At one end, at end points. Yes or no? End points. Yes or no? End points na? Copy this. Copy this. At end points. Copy 1. In case 1, you can also write case 1. Okay. At end points. At end points. And at points theta, you can write theta 1 equal to 90 and theta 2 equal to 180. And then you solve. You copy this. Should I write it freshly? Yeah, or you can understand. You can understand, na? Copy this and this and this finally. Okay. Means copy first. Then I will talk. It got decreased or increased? Tell me if it is of infinite length. Actually, it will decrease. I don't know what is in between them. Na? What is the formula in between them? I will tell you. First, you got this idea. Na? What is the formula here? It got decreased. How? I don't have what is the magnitude between them if it is of infinite length. If it is of infinite length. I will express this. Then I will compare with this. Okay. Copy this now. Okay. What about if the length is infinite? What about if the length is infinite? If the length of the solenoid is infinite, tell me if it is infinity. Infinity, already told you no. If actually length should not be infinite. If the radius of the solenoid is very small and length is this much, is it of infinite length? According to the radius. Yes, na? Because radius is very small. Compared to this, it is large, na? It is more than large means it is infinite. It is of infinite length. Yes or no? Clear, na? Let's say the radius is very small. That's why the length will be infinity. Now, tell me the angles. What will be the angle cos theta 1 and cos theta 2? In means I want to calculate in between them, not at the ends. Okay, at any point, but not at the ends. Case 2 means for infinitely long solenoid. Okay, means theta 1 equal to, if it is of infinite length, I want to calculate it here. Okay, can you think like this? If it is infinite, is it 0 approximately? Theta 1 is 0. What about theta 2? It is infinity also. Is it 180? Yes or? Means it is 180. B mu naught and I upon 2 cos 180 minus cos 0. Yes or no? What will be this result? Mu naught n I by 2 into minus 1 minus 1. Yes or no? Cos 180 minus 1 minus cos 0 1. Yes or no? Minus 1 minus 2 minus 1 minus 1 minus 2. It will be mod minus mu ni, because negative can't be possible. It will be what? Mu naught ni. Yes or no? Clear now? Tell me, is it double of this?
Yes.
Means inside the solenoid what will be magnitude? Double of the ends. Double of the magnitude at, means at the ends it got decreased to half. At the ends, not the gradually actually. Means it will gradually, but at the ends. Throughout the length, what was the magnitude? Mu naught ni. At the ends, it got decreased to mu naught ni by 2. Clear? Okay, copy this. Washroom? Yeah, sure. Come fast. Okay, sure. Come in. Okay, listen, let's talk about toroid. Have you heard this name? What is this? A solenoid but in circular form. It was straight now? Yes or no? If you will convert this solenoid into circular, means circle, it will be called what? It will be called what? Is it okay? Is it visible to everyone?
Yes.
Okay, it will be called what? If I imagine this was solenoid. Is this visible to you? Solenoid, no. Okay, this is a straight solenoid. I made it in circular form. Getting my point? I carved it into circle. Clear? It will become what? Toroid. It will become toroid. Okay. Means it is like this. Actually not becoming proper. Let me draw the figure properly, then I will. Actually, there are two concentric circles. Hey, don't do make a noise. Two concentric circles are there, and over this circle there are rings. Oh, actually these are like this. Oh, not drawing properly. Yeah, what is happening here? It was like that, no? The wires gone over the what? Over the soft core, or it may be soft iron core. Okay. I will teach you why soft iron core. Okay. Okay, this is the solenoid. Can you imagine? And let's say the current was coming through this, and the current went through this. Okay. The current was coming through this, and current went through this. Is it the solenoid circular form of solenoid or no? Yes or no? Means the solenoid was straight. I made it circular. Yes or no? Yes. Okay. Tell me. I want to calculate magnitude of magnetic field at. There are three positions, no? Actually, in solenoid there were two positions, inside and outside. What about this? There are two outsides. Yes, this one, and one is in between the solenoid. Means one inside, means inner outside, one in between the solenoid and toroid, inner outside. Means I have the nomenclature, new nomenclature. This is inner outside, this is outer outside. Clear? I invented a new word in between. Okay, this is inner outside, this is outer outside. Okay, now I want to calculate magnetic field here, here, and here. Clear? What will be magnetic field here? Before going into the toroid, I want to recall you Ampere circuit law. What is that? Ampere circuit law. And if you go with the Ampere circuit law, you will find the idea how to calculate magnetic field. I want to calculate magnetic field here. Means what? I will draw a imaginary circle. Yes or no?
Yes, sir.
Is there any current passing through this solid circular loop? Means hypothetical loop?
No.
Yes or no? No, no? Means what will be the magnetic field at P1? At P1. B equal to what? 0 na? Why? Why? You got na? Is it? Okay, let it be. No problem. You guys are feeling cold?
No, it's okay.
It's okay na?
Yeah.
Let's enjoy this environment. Okay, no problem. Why? Because close integral of b dl cos 0 equal to mu naught I total, it was 0 na?
Yes.
B will be equal to 0. Yes or no? Okay. What about the outside one? I want to calculate P3. Means at P3. This is P3. At P3, what will be magnetic field? 0. Why? Because close integral of B dl cos 0 equal to mu naught. What 0? Why 0? I am telling you. You will say, sir, no 0, sir. Inside there is magnet. Current, na? There is current, na? Yes or no? No, there is no current. Why? I am telling you, na? If this is the loop, okay? If this is the loop, I current came, means I current cross this loop. Okay. Again, I current went inside the loop. Means I am taking outside loop. Na? I am talking about this. One current came, one current down. What will be net? I plus, I minus. 0. In each ring there is happening. Na? This is happening in each ring. One current coming, one current going. One current coming, one current going. Yes or no?
Yes, sir.
Getting everyone or no? Means what will be the net current threading this loop, coming and down, going? 0 na? Yes or no? I am talking about this plane na. Loop means it is 2 dimension na. Loop means circle na. If you crossing the circle, it is plus I. If going into the circle, means inside the circle, it is minus I. In each ring, one time it comes and one time it goes. Yes or no? Yes or no? Total will be clear. That's why it is what now? Got the idea? What about here? P2. At P2. Here it will not be 0. Why? I'm telling you. Just imagine a circular wire, circular ring. Okay. Now, if you imagine a circular ring, what will be cross integral to B dl? Cos 0 will be there, na? Why? I already told you why cos 0 will be there. Okay. Imagine there is current inside this. Okay. The magnetic field length and the magnetic field and the length direction will be same, na? I already told you. What about this? This was mu naught. I total, na? Yes or no? I total. Okay. Let me explain it here. One more thing. Is it I? No. There should be and also, na? Wait. How many currents are passing in this? Imagine. This is 2 pi r, na? Okay, no problem. This is mu naught I. I current was passing through, na? Actually, not I. What? I current passing through one ring, na? Yes or no? This. I crossed. Again I crossed. Yes or no? Again I crossed. Means how many eyes are there? N? Yes or no? Yes or no?
Yes.
Now you got. What is the length dl? 2 pi. What are? There are 2 radius, no? One is inner radius R1 and one is outer radius. What R you are talking about? you are talking about the middle one. Yes or no? Means what? R mean. R mean means R1 plus R2 by 2. Yes or no? What is the radius you are talking about? R1 plus R2 by 2. Here 2 pi capital R means RB. Clear? Yes or no? You are talking about in between them na? You will have to take mean. Why? No. R2 minus R1 is this length na? Yes. Am I talking about this length? No. I am talking about this length na? Yes or no? Means from here na? R2 minus R1 is this. If I am taking division of 2, it will also reduce again. Yes or no? I am talking about this length. Clear? Means mean of the radius. Okay? Now, it will what? B into 2 pi R equal to mu naught n I by, take this there. Yes or no? B equal to mu naught n upon 2 pi R into I. Actually, what is this? N upon 2 pi R. Number of turns per unit length. Is it perimeter? Yes or no? It is circumference. Yes. Means mu naught and the formula is the same as that of what? Solenoid. Yes, no? As that of solenoid of infinite length. Yes or no? The formula is same as that of formula of solenoid of infinite length. Yes or no? Copy this. Copy this. This is of toroid. Clear? And outside is 0. That means outer outside is 0. Inner and outside is 0. What about in between them? Is mu naught Ni. Clear? Copy. Yeah. Magnetic field due to an infinite solenoid using what? Ampere's circuital law. Okay, I'm doing it. Everyone listen only. If get the heading, listen. I choose what? A rectangular section here. Okay, or a square section. It will be very easy. It is a square section. The length of this section is L, and L. Clear? Why I choose this? I want to calculate magnetic field here. Okay? Here. Means in between the solenoid na? Okay. And using this, I didn't choose circular section. Why? Because that will not symmetric according to this. Yes or no? Okay. Tell me, if the magnetic direction of magnetic field is here or here, I don't know, because of according to the current, let's say this is here in this direction. Okay, there is the magnetic field direction. Where is the length? Direction of length? I am taking A, B, C, D. AB is in this direction, no? Means both are in the same direction. What is the angle between them? 0. What about magnetic field here? Oh, no, outside is 0. What about magnetic field here inside, in between the coil? Here. What is the length? There, no? Means BC, B to C. Length. What is the angle? 90. Here, magnetic field in this direction. Length is in this direction. What is the angle? 180. Here 0. What about this? Magnetic field is actually outside is 0 now. Here 0. Here there is magnetic field. Inside this. B is this and length is here. What is this? 90 degree now? Yes or no? Here 90, here 90, here 180. There is no magnetic field. Actually B is equal to 0 here now. Outside the solenoid it is 0 now. There is no magnetic field. There is no magnetic field. I mean 90, 90 and 0. There will be 0 and only there is there. Means using what? Ampere's circuital law. What is this? Close integral of BdL. Close means A, B, C, D. A, B, C, D. Yes or no? Equal to, should be equal to what? B dot dl. It is B dot dl. I am writing it in vector form. Mu naught I total na? Yes or no? I total. Okay. Okay. Is it I total? It is. I'm not writing I. I is another thing here. I will put in form of I. Okay, no problem. Now, how many loop? Means this is loop na? There are 4 sections of this loop here. Yes or no? There are 4 part of this loop. Separate them. Okay. What is that? First one is B. Let's talk about this. B DL cos 0. From where to where? A to B. Yes or no? B to C. B DL cos 90. Yes or no? B DL cos 180. Yes or no? CD? No. BC. BC CD. Plus. From where to where? B DL cos again 90 from DA. Yes or no? Equal to mu naught. Is it? How many number of terms inside this? Is it 1? No. Means let's say n number of turns per unit length. Means n into, I'm taking L length na, n into L into I. Yes or no? Tell me. Why I'm taking NL? Means number of turns per unit length n into L, means total number of turns here into I. How many turns are there? Not n into L turns are there. Yes or no? Small n into L. Total number of turns and how many currents? N currents, na? That's why. And L into I. Clear? Clear? This term clear or no? This is I actually. Clear? But what I? Is it single? No. N i's are there, na? Because n turns was inside this length. Yes or no? Now it is what? Some value. It is 0 because of 90, because of cos 180, and there is no magnetic field, na? Clear? Is there magnetic field outside? No. This is also 0 because of 90. Yes or no? Only we have this term, na? What is this? B dl cos 01 means B into, what is dl actually? L, na? Yes or no? What about this? Mu naught n L I. L L cancel. What is this? B equal to mu naught n I. We got the result, na? What we got from basics, na? Yes or no? Using Ampere circuit law. Okay, copy this. If the current is coming like this, okay, magnetic field direction is here. Will it be like this? Yes or no? Yes or no? Tell me, is this uniform inside this solenoid? Yes or no? This is uniform inside the solenoid but not uniform outside the solenoid. Here. Is it uniform? Not, na? Means at the end, is it uniform? No. Actually it was decreasing, na? It was, means at the just, means at the end it is uniform. Just at the end. Just beyond that it is not uniform. Clear? It was actually decreasing. Yes or no? It was decreasing, na? That's why at the end what is this? Mu naught Ni by 2, na? Yes or no? And what about in between, inside the solenoid? Mu naught Ni. Yes, na? Okay. Okay. Clear, na? Why it is inside this is uniform. Outside this is not uniform actually. This was decreasing. Yes or no? Clear? I want to draw the graph. I want to draw the graph of B and X distance. Okay. Is it like this? Imagine. And at the ends, It got decreased, na? Yes or no? Yes or no? Why I am drawing like this? Can you imagine? Where it is minus L by 2? Yes or no? Where it is? Where it is? Plus L by 2. Because the length is L, na? Yes or no? I am talking about, this is the midpoint, means mid. Yes or no? This is, what is the magnitude here? Half. Take it half. Don't take it like this. Yeah, half. It is half actually. Clear? Clear? It is half, na, of this. This is B equal to mu naught Ni. And what about this? B equal to mu naught Ni by 2. Yes or no? Yes or no? Here at the end it got decreased. Actually it is not sudden decrease, zero, a sudden half. It got decreased gradually, but in this way. Okay? Got this idea? No? Okay. If I connect another solenoid with this, it will automatically be uniform. Again, it will continue. Yes or no? Clear? No? Yes. Helmholtz coil arrangement. What were there? In between, when the curvature was changing, it got connected another. Yes or no? Yes. Okay. Copy this. This is the graph of B and X. This is X length, no? Distance actually. Length. B and L. Okay. This is a straight line. You can see. Is it a straight line? No, do not look straight line. Do straight line. Okay. Is it straight? It is a straight line. Constant inside the solenoid, and at the ends it got decreased. What are you doing? Oh. No. Okay. Do you want to solve questions? Okay. Let's solve a few questions and then I will proceed. Okay. Copy it now? Okay, copy. Then let me dictate a question. Write the question. Okay, wait. Six. There are 5 students, na? Left? 3 in washroom. Oh, 3 are there. 2 in washroom. Okay. They are sleeping now, right now?
No.
What they are
Reading.
Huh?
Reading.
What?
पढ़ाई करना.
पढ़ाई कर रहा है?
वो आता है बिस्तर से रात से sleeping.
Yeah, sleep करना मना नहीं है. You can sleep. You do sleep. When I'm telling you, always take the proper sleep. But yeah, classes छोड़ के नहीं.
उंगली आता है.
Okay.
वो दोनों का.
मैं देखता हूँ. क्योंकि
आप एक दिन में कितने घंटा सोता है? वो
7 hours at least. Do take proper sleep. 6 to 7 hours at least. If you are not taking 6 hours at least, means I'm not recommending you to sleep 7 hours because This is my time to sleep. This is not your time. But sleep at least 6 hours. You can cut the hours from sleep. हाँ? ओ पढ़ते थे जो हाँ 6 hours was enough. Actually, I used to wake up in the morning at 3. Yeah, during my studies at 3. My eyes automatically got open because I had some extra force from back side to do better than the others. Yes, so, and even there was competition now. You have also competition. There are so many working hard. You are still sleeping. You will be get rejected definitely if you are doing this because there are so many now. This is competition examination. This is not like you will pass the cutoff and you are safe. No. Your safe is by defeating other. This is just a battle, but not physical, but mental. This is the battle. If the opponent is working hard, you will have to work hard. Better than him. Yes or no?
Sure.
There is no compromise. No? You will have to work hard. If you got top in first examination, like Altaf, don't be arrogant like this because I'm telling you honestly, when I did top, after this he is very casual. Don't do like this. Don't take it granted. It doesn't signify that you can succeed in the examination. Consistency will lead your success. Your success depends on your consistency, not depend on your first time top. Okay, there are so many who work hard and do better in the tests but can't result in the final marks because of continuity. You got good result. No, I'm wishing you guys well, but consistency will matter. There are so many who were weak during the class time and their result in the test was not that much good, but they were working hard. Got selected in the medical college now. There are so many examples. So, whatever I'm telling, it may be ideal. It may look ideal. It may seem like ideal, but this is the only formula. I know you can't. No one can be ideal person, na? But ideal is the rule, na? You will have to follow at least that, na? Otherwise, you will get disqualified. Because during my childhood or during my student period, we were thinking, no, because according to me this is good and I should do this. I realize right now, no, there is no according to me. Actually, you are not in that period to think correctly. Whenever you are in present time, you can't decide what you are doing. Actually, after 1 year, 2 years, you can realize, oh, I was doing very wrong thing. No one was there to stop me because you are not able to understand what is going on, what happening with you, and what you should do properly. Yeah, there are so many, and you will talk. This should be done. This should. Your battle is your own. You should try to follow the ideal paths right now, at least. Ideal path means do work hard, appear in the tests, attend the classes. These are things you should follow. You all should follow. But according to your weakness, how long you study in self-study, how much time you dedicate to the self-study, according to your strength, do it. If you are most brilliant one, you can manage it in 4 hours, 5 hours. If you are weak and you can't understand the thing in one way, in one time, then you will have to dedicate. Instead of 5 hours, you will have to dedicate 10 hours so that you can compete the others. Yeah, definitely you can compete. If there is brilliant one and there is weak one, nothing differences between them. If they are dedicating, different times. One is studying 10 hours, one is studying 5 hours. 10 hours can beat the 5 hours. Working hard and working consistently is matter. Okay. So work hard and definitely will get success. Definitely. Okay. Sometimes you can be demoralized because of because you are not scoring well in the test. Yeah, this is genuine and this should be. It's okay. But give lesson from each test. You will work hard. And you will definitely do better. You can analyze yourself after at the end of this session, means classes. You can analyze, you will have lot of knowledges. Clear? Okay. Okay. Let's start. What I were talking? Let's do what? Motion of charged particle in uniform, everyone understand, uniform magnetic field. Okay, motion of charged particle in uniform magnetic field. Give the heading. Where is the duster? Give the heading. Motion of charged particle. Oh, question, no?
Yes.
Okay, I will do it later. First, do it. Oh, you first do the questions. Do the questions. I left the questions, no?